difficult. This is the more difficult stuff, if you will. A lot of what we're going to do today is review from what we already know. We're dealing with parabolas. Now, you guys know what a parabola is already, especially in terms of quadratics. The parabolas on the quadratics are going up or down, opening up or down. The U-shaped graph that opens up or down. Those are quadratic functions, okay, assuming they pass the vertical line test and so forth. Now, we're going to start talking about the opening left and right, the C and the backward C parabolas. Okay, those are just not quadratic functions, but we are going to be able to deal with them like we deal with the other ones. So a parabola is a set of all points in a plane that are the same distance from a given point called the focus. The focus is a point, and that is one of your new items. Okay, and a given line called the directrix. Okay, and again, that's a new item as well, and we'll talk more about that as we go. All right, moving ahead.
Should we draw that graph?
I wouldn't worry too much about that. You'll get that in a minute. Okay, what we're going to do is that's our standard form. What else do we call that before? Vertex form. The hardest part of this unit in my mind is going to be remembering how to put something in vertex form. Because when we put something in vertex form, we are going to have to complete the square. Completing the square is what many of you struggled on, several months ago. The other thing is, for you guys that just recently came over from Ms. Escobar's class, I know you've already gone over the conic section, but it is a little different because you guys deal with p-value. We don't deal with that p-value, okay? And so it's going to seem a little different. The p-value is easier, I think, because you're just moving in whole units of p, okay, or whatever. This value that we're going to talk about is a little more complicated. It is the way it is. Just we go by the red textbook, and the red textbook goes this way. Green textbook goes a different way. Okay, so you just kind of have to follow along here. The first thing we're going to do, though, is we need to make sure that we take our standard quadratic form, y equals ax squared plus bx plus c. We're going to have to turn that into the standard vertex form. The standard form, y equals a times x minus h squared plus k. Again, your vertex, and again, this is all review. Your vertex is at h and k. Assuming that this is just a normal parabola, your vertex is at h and k. And axis of symmetry is at x equals h. And if a is greater than 0, then the k is a minimum and it opens upward. So if a is positive, your parabola is going to open upward. Okay. If a is less than 0, then k is a maximum and it's going to open downward. So if a is negative, it opens downward. And this is all based on this standard form of y equals a times x minus h squared plus k. And again, this is what we already know, and we'll add to this as we go, which you've already started doing that with those notes that you took ahead of time. Okay? So here's our first example. We're going to write y equals negative x squared plus, or minus 2x plus 3 in vertex form, or in standard form, and identify the vertex, axis of symmetry, and direction of opening. Okay? So, let's go ahead and get started. The first thing is, I'm just going to rewrite this so I can manipulate it. Negative x squared minus 2x plus 3. Okay, I want this to turn into y equals a times what? X minus h squared plus k. All right, so that's what I need to convert it to. So if you remember from our previous unit, now here's the deal, and I'm going to kind of go slower over this because I want to kind of review this. I want to make sure that we get this again. But the reality is that at this point and where we are in the year, you should know how to complete the square. You should know how to do this. Okay, I'm going to spend a little more time than I probably should because I know this is the hardest part. Because I know you struggled with it before. I'm willing to bet you'll struggle again. So make sure you pay attention. But once we get started, there's not a ton of examples on converting the form. It's more about you knowing how to do it and then going from there and graphing. There's going to be quite a bit of graphing. Okay, so the first thing you do, if you remember, is we did this. We said, okay, x minus 2x, and we put that in parentheses, and then we left plus 3 out. Okay, we did that because ideally what we want to do is we would normally subtract this from both sides, right? So subtract 3 from both sides, it would be over here, so that way we'd have this parentheses, and that would be our starting part of the setup. But then we'd bring it right back, right? So when we brought it right back, we just add it back in there. So rather than subtracting it and then adding it back, we just went ahead and just take it out of the parentheses. That was kind of that shortcut method. Okay, the next thing is this. Do I want a negative x value? No, so I need to go ahead and, I have to factor out that negative 1. And that's going to give me negative times what? X squared plus 2x. Now if you remember, this is where we have the plus blank, okay, plus 3 minus blank. Okay, this is where we're talking about our, completing the square in order to get us into that standard vertex form. Okay, so if you remember, how do I get this blank here?
You divide by 2.
I divide what by 2?
2, the 2.
I divide the 2, the b term by 2, and square it. Very good. So if I divide it by 2, I get what? 1. And then I square it, I get 1.
So you add 1 to the next one.
Okay, hang on. Now, 1 goes there. If I have nothing out here, okay, that would be assuming that a is what? 1, if there's nothing out here. So if a is 1, then I put this here and this here. But a is not 1. A is negative 1, so I've got to take into account this negative. So I would multiply this negative, or whatever number's in front, times this, and that's what goes out there. So out here, I would put negative 1. So then it will turn into plus because of the double signs.
How did you get the first one? I didn't catch it.
First what?
The first one that you
Yeah.
put in the parentheses. Divide by 2.
Yeah, and I'm going to do a little football diagramming here for you guys because this term right here, the way you get this term right here, again, is b divided by 2 squared. Okay, and again, the same concept here, because ideally what would happen is I would say, okay, negative 1 times 1 is negative 1. Okay, then I would add it to both sides, because if I do it to one side, I've got to do it to the other side. So I would add it to both sides. Okay, and then I would bring it back over here. And that's where the negative 1 comes back to. Okay, that's why this minus comes back. Okay, so if I put a negative 1 here, because that's essentially what that is, right? If I put a negative 1 here, I'll put a negative 1 here, and then I've got to subtract it back away. So that's why it is that weird setup. But if you just remember these little steps that we do, you'll be okay. Okay? Again, and I hate to say it this way, but where most of you are and what class that we're in, if you don't ask too many questions of, well, why does it work like that? Why does it work like that? And I'm not a big advocate of that, but if that's just getting through where we are, then it'll be a little easier. If you want to know why, we can talk more about it later after or before school. Okay, but this is one of those sections that investigating why gets it more complicated. It makes you more confused. Okay? All right, now, as I continue, okay, I go ahead and ultimately what I did here is I created a perfect square trinomial. This x squared plus 2x plus 1 is a perfect square trinomial. If you memorize the form, you would know the factors right away. So what do I put down here? I have negative what? X plus 1 squared. If you know perfect square trinomials, you know that basically you're taking the square root of this, the square root of this, the same sign as the first one, and squaring. We didn't talk about that the first time because I didn't know where you guys were on perfect square trinomials. But I do teach my freshmen this, so they know perfect square trinomials. Well, they should know perfect square trinomials. Okay? Now, the other way you can look at this as taking half of this, right? You took your x out, and then you took half of this, and then squared.
You take half of it every time?
Every time. Okay?
Just take half of
B term. Okay? And then outside here, okay, I'm going to go ahead and simplify these right here. So then I'm going to end up with plus 4. Okay? Am I in vertex form now? Yes, I am. Okay, now, that's not the whole part. That just gets us to where I need to be so that I can answer the rest of the questions. Okay, so the first question was vertex. Based on what we know, vertex is what?
H and K.
Vertex is HK, right? H comma K. So with that being said, let's go ahead and identify A, which is -1. H is no. H is what, Brandon Hall? -1, because remember, if you look at the formula here, this says opposite of H. Okay, so the opposite of H. So that means if this is ended up being a plus, that means the opposite of that would be negative. So H is -1. And then K is 4. K is just K, right? So if our vertex is H comma K, our vertex is then -1 comma 4. Okay. What about our axis of symmetry? X equals H. Okay. Axis of symmetry, I'm just going to put AOS so we know what that is. X equals what? -1. Because this makes sense because our parabola here, because it's just a standard, parabola. Which way is it opening? Down. Okay. It's a standard parabola that opens downward. We know it's going to be a vertical line. Vertical lines are identified by X equals. Okay. And the vertical line is going to go through the vertex because the vertex is the middle, right, of that parabola. So the vertex, the axis of symmetry cuts it in half. So it only makes sense it's going to go through that X equals the H, or X equals -1. And then finally our last one we already talked about, it is going to open downward. Okay. Why is it going to open downward? Because A is less than 0, or A is negative. Very good.
So it all just depends on A. You could just say that if it's negative or positive.
Right. Yes. Okay. Now, little extension questions are, how does this compare to standard the parent quadratic? What is the parent quadratic? No.
Or A squared.
No. Y equals X squared. Okay, Y, you're thinking of standard. Y equals X squared, which is a parabola. Which direction is it open? Up. How does this compare?
Down.
That one's down. What else do you know about this? Okay, no, the size is not the same.
The y-intercept is 3 or 4.
Okay, say again. Okay, the vertex is different. That's what's going to actually tell us our change. So the vertex of the parent quadratic is the origin 0, 0. So now based on the vertex of this one, tell me what happened. It shifted to the left 1, okay, and then it went up 4. You don't have to say it shifted to the left -1 because shifting to the left means negative. So you shifted to the left 1, and you don't even have to say it went up because positive 4, because up is positive. Okay? So compared to our parent quadratic, we shifted to the left 1, we went up 4 units. Okay? And then of course it's downward instead of upward. Any questions? Okay, again, I really think the hardest part is getting the quadratic. Getting into vertex standard form. If you can do that, you're fine. The rest of it is just filling in stuff. Okay? All right, here we go.
Okay.
All right, it's there.
I was gonna say I'm still confused. I mean, I get the rationale behind why H is -1, but it just doesn't make sense because it's the opposite of H.
Look at the formula. It says negative.
Very good, Marcus. Marcus said, I'm not listening because I get it right now. I get it right now. Not listening. Don't confuse me. All right, seriously, what's your question then?
I don't understand
Because we got
H
H.
is
We got
-1. I'm asking him, not you.
You don't understand why H is -1?
Yeah.
Okay, again. Okay, K. You understand how K is 4, right?
Yeah.
This is positive right here. So it's basically saying whatever K is K.
Yeah.
If you think about negative being opposite, this is saying, hey, you're going to take the opposite of H and put that into your formulas. So if the opposite of H, if H is -1, the opposite of H, okay, is going to go in here as a +1. So in order for this to be true, basically what you're looking at is negative, negative 1. Because this is x minus h, right? The only way you can get only way you can get plus is by having negative, negative.
Okay.
You see that? Does that help
Yeah,
a
I
little
get
bit?
it now.
Okay. All right. Any other questions?
No.
All right. Moving on. Very good statement. All right, now we're going to look at these real quick, and I'm going to go ahead and quickly sketch these graphs so that you can label them along with me, because that's going to help you identify some of the new parts that we were talking about. I'm going to add stuff to them as best as I can.
Took a picture of this on for right now.
Wood technology is great. You're not gonna sketch this like I asked you to nicely.
Is the dotted line the...
Huh? No.
What?
Okay.
That
I'm
was you
listening.
asking?
Yeah, I was like, go ahead and sketch this real quick.
You
Yeah.
didn't.
I didn't say that. I
You were
don't.
gonna
You
sketch
did
it.
say that.
Oh, I said you go ahead and sketch this so that
You
you.
were gonna sketch it.
Even Amy's sketching it. I mean, it's, she heard.
I'm
We
sorry.
can just do it. He's already, they must have
Just
given
wait
you
for
some
him,
medication.
Please, sure, no problem.
What?
I said they must have given you some like medication or something.
Yeah, I'm on 6 different medications.
I thought it was 9.
I'll go
Why are you in the
home.
hospital?
You're getting back.
Gotcha.
Yeah, what happened?
Let's not talk about that right now. Let's keep moving. I don't want to hear all the gory details.
She died.
Okay,
I did.
now, in addition to finding the vertex, axis of symmetry, and which direction it opens, up or down, we're also going to need to find the focus, which is our new deal, the directrix, which is our new deal, and the length of the LR for a parabola. Okay? So, let's go ahead and take a look at what we're talking about here. Now, this line right here, okay, that is our directrix. I'm just going to label it with the D. I would, in your notes, I would actually write the word directrix, but because my pen writes so largely, I'm not going to do that. So that's our directrix. Notice where the directrix is. Where is the directrix located?
Above the x-axis.
Okay, good observation here, but compare it to the parabola itself. Where is it located?
Parabola.
It's below the
Parabola.
Below the
vertex. Below the vertex. Okay? What do you think if I flip the vertex? Where would it be? Above the vertex. So if the vertex was, if the parabola was opening in the downward direction, then my directrix would be above it. Okay? Now, with that being said, one of the things that some of you should have been copying down was that the distance here. What is the distance from the directrix to the vertex? 2.
Okay.
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 Okay. It's 1 over 4a. Excuse me. Yes, 1 over 4a. So here is 1 over 4a. So the distance from this point right here to the directrix is 1 over 4a. Okay? Okay? And what is the vertical line, dash line? Yeah, that's just the axis of symmetry, so we're not going to talk too much about that. You guys know what that is. Okay? Now, this point right here, oh, you can't see it. That's not the greatest color. That is the focus.
Where?
Right there.
Yeah.
Sorry. I used a blue, sorry. That's the focus point, okay? And it's a point. Now, if you have this chart already started, this particular parabola goes with this chart. So in this particular case, our focus is going to be located at H, whatever our H is in our equation, comma, K plus 1/4 A. So that's how you find this, okay? So that's where you get your point. But if I have my parabola drawn, what's the distance from the focus to the vertex? Not 1. What's the difference between the parabola or the vertex and the directrix is 1/4 A, right? What's the distance between the directrix and the focus? 1/4 A. That would have been the best guess, right? So this is also 1/4 A. I know, it's hard to see, sorry, but it is what it is. I said it so that you could write it. Okay? Now, our next thing right here, this is called the LR. Okay?
Where's this?
See that yellow line?
It's this little yellow line right here that goes from here to here. That's your LR. That's the total distance for your LR is what? Anybody know? Yeah, absolute value of 1 over A units. That's the total distance of your LR, the length of your LR. So if I'm asking you this, what's the distance between this point here and my focus?
Half.
So 1 over 2A. Okay, so that distance is 1 over 2A. And then, of course, on the other side, it's 1 over
Is it the absolute
2A. And yes, it is absolute value of those.
1 over 2A, absolute value of that?
Yep.
That's only halfway.
Yeah, so put them together, 2 halves gives you the whole, right? So here you go. Okay.
Will we ever use the
No, it gives you 2 over 2. You're multiplying. Adding 1 and 1 is 2 over 2 is 1. I'm sorry, one more time.
Are you just giving us that, or will we ever use that?
No, you'll need this. Yes, you'll need to use this. Yeah. Because realistically, when you start to graph these, what you'll do is you'll figure out that distance, because all you need to know to find that distance is A. So if A is 2, so you would be 1 over 2 times A.
That'd be one that way.
Well, it'd be 1 over 2 times 1/8, right? Okay? So absolute value of 1/8, and then it'd be 1/8 this direction, 1/8 this direction. Okay? So you'll use that as you get A. Okay? All right. And that'll help you graph, and you'll see that as you move forward from this. And vertex is down there. You know where the vertex is. That's pretty simple. And then those other points are just random. Point A and B. And of course, they're equidistant from the vertex. Right? Okay? Hang on. Okay. Now, on the other side, you essentially have the same thing. So I'm not going to write everything down again, but what is this? Directrix. What is this?
Focus.
LR. Okay. What is this? Focus. Okay. What is this? Axis of symmetry. What is this? Oops. Almost missed it. Vertex. Okay. And that's pretty much all you need to know. And again, they all work the same, okay? Except now this difference here is the graph is moving, the parabola is opening right versus left, right? But everything else works the same. What's this? This measurement.
1 over 2A.
1 over 2A.
Absolute value of 1 over 2A. Absolute value of 1 over 2A. Okay? The distance from here to here. 1 over 4A. Distance from here to here. 1 over 4A. Okay? Alright. Now, I'm going to go ahead and move this up a little bit so that we can see the entire chart again. Now notice on this chart, again, this is 2 separately distinct. It's basically a table. Okay, so you have 2 sides here. What is the difference between this and this? X and Y are flipped. What do we call that when we do that? Essentially, they're inverses of one another. Which is why instead of up and down, you're opening on the X equals, you're opening left and right. Okay? Now, an easy way to remember this is when you're dealing with, because the question might come up, well, what do you do, how do you know, okay, which one to use. Because a lot of times we're starting in standard quadratic, some form of quadratic, okay? Well, if your x is squared, then you're going to have the up and down. If your y is squared, then you're going to have the left and right. You'll solve for x instead of y. Over here you solve for y, right? So you just switch it if your y is squared. Okay, whatever term is squared, solve for the other one. Okay? Now, and if you notice, the vertex is still the same. But look at the axis of symmetry. Why did this change? What kind of line is this?
Vertical.
Yeah, that's a vertical line.
The other's horizontal.
The other one is horizontal. So this is a vertical line. Why does that make sense?
Because it's goes up and down.
Yeah, because it goes up and down with the parabola, right? And the other one is a horizontal line. You can read that. Okay.
Solid.
Notice where the focus changes from.
It looks like.
There's an L in there. Okay. Notice where how the focus changes. The focus, the H is left alone on the up and down. The K is the one that you add that 1/4 A to. On the other one, you're adding 1/4 A to the H instead of the K. Okay. The directrix. Okay. What kind of line was the directrix before? What kind of line is this?
That
That's a horizontal line. Okay, now it's vertical. I'm sorry, this is a horizontal line. Over here it's vertical. Okay, because it's x equals. And again, this isn't an equation. This is not like y equals mx plus b. This is going to say, hey, take that k value, plug your a value in there, and then subtract, and then you have one number that'll create that line. Okay? Here, if your a is greater than 0, you're opening up. A is less than 0, you're opening down. That's what we talked about at the very beginning. But now, if your a is greater than 0, you're opening which way? To the right? To the left. So positive to the right, left, negative.
We can base that one off a basic number line, right?
Yeah, I was going to ask that question. I'm glad you said that because I was going to say, why does that make sense? It makes sense because on a number line, your positive numbers are to the right, your negative numbers are to the left. Okay?
You're so weird.
Now, did the length of the LR change at all? No. Okay.
You're so weird.
All right, any questions on that?
totally off topic. Did you see the last pitch in the Rangers game?
Yes, it was a ball. But anyhow, we got to keep moving because I want to cover one more thing for you because basically the rest of what you're doing is plugging in. Okay, now, but I do want to show you this because this is what Aiden was asking about. Can we convert one of these? This is a little different. So if I want to convert this, what am I solving for? I'm solving for what by itself? Say it again. I'm x equals. So I'm still going to complete the square like normal. But I want x by itself, so I've got to subtract the y squared from both sides. So now I have x plus, x equals negative y squared plus 4y minus 1. Just like before. Anybody lost on that? All I did was subtract y squared from both sides. Put in parentheses and leave out that negative 1. Okay? Now you have x equals, what do I got to take out of there? The negative. And that's going to give me y squared minus 4y. Minus, you're right. Thank you, Colton. Plus my blank spot, minus 1, minus a blank spot, right? What goes in that blank spot?
4.
Okay, 4, because negative 4 divided by 2 is negative 2. Negative 2 squared is 4. Okay? What goes here? And I'm sorry, in the last blank. Negative 4. Because I'm taking this negative times the 4 and putting the negative 4 down there. Okay? So now, I do my perfect square trinomial. I get negative what? Y minus 2 squared plus 3.
Just to be clear, if that wasn't a negative out there, it would just be positive.
So the
negative A changes it.
I'm sorry, one more
The
time.
negative,
This is negative, so it's positive. Yeah.
but if there wasn't a negative. it would-
Then this would just be 4 down here. Yes. Okay. Now, from here, what your job would be to do is to graph this. Okay? So what you could do is, can you find the vertex now?
Yes.
HK. Can you find the axis of symmetry? Yes. Can you determine, does it open left or right?
Yes, opens
It opens to the left because it's negative. Can I find the directrix? Yes. Can I find all these things? Yes, because I have A, H, and K. Okay, I got it. I'm asking questions to make sure you understand.
We understand
Okay?
with the homework.
The homework. Yes, sir. You ever?
So when it's an X equals that B, it's gonna be opening left and right?
Absolutely. Good. He said when it's X equals, it's going to be opening left to right. Right? I said yes. Okay. The homework is on Blackboard.